Welcome to a new test and teardown video. This time it's a medical product called Midi Term. It's from Pfizer and it's called TWP02. That is the model number. And it runs on 230 volts, 350 watts. And I bet it has something to do with what this one is doing. I think you got some thermal pads, you put them around your legs and different parts of your body, and then you connect them to those four connectors right here. Those are just 4-pin DIN, so it can't be a lot of current per output, and it can also not be a lot of voltage because it should be patient safe. So I bet it's 12 or 24 volts per output, something low and safe. And then I don't know how many amps can you do, like 5 amps? Maybe that adds up if it's something like that. But I think the idea is you have these buttons here where you can change the hours, 0 to 10 hours. Really? But here it's minutes. So this is confusing. One leg is only in minutes and the other leg is hours. I kind of don't get it. Then we got some total, warm up. Maybe that is the idea. I don't know. More minutes. So it's all about time. So maybe it's just some on-off system or something like that. So now we're inside and it is incredibly beautifully designed. But one thing I freaked out about is, look at that groove here. This is to the front panel. And then we had this little piece of plastic sticking out. And then I pulled and this is the front plate label. So, I mean, you could just print your own and put this in. So they are sold under all sorts of different names. And all you do is stick in a new little name tag. Here you go. And bada bing, bada bum, you have whatever the customer wants to call this product. So this explains, of course, why I cannot Google anything like this. And the sticker on the back, maybe I should show that one. So here's the sticker on the back. It says this Pfeiffer Midi. But there's another funny thing. Here on the circuit board, Pfeiffer.dk. So that helps me a little bit. We got a year info here, 2005. And again, Pfeiffer. So this big, massive transformer, we got the two main windings, 115 and 115. And then in the middle between them, we got this NTC. And that is a good way to do it as well. There's probably a mains fuse here. All that is fine. Earth, good to chassis. Extra chassis winding to extra wire here to the front panel for safety. All that is perfectly good. And we got some funny things about the controller board and also the transformer secondary windings. So that will be 12 volts and that will be plus minus 12 volts. Why are they doing that? And each of these are 6.3 amps, and 6.3 amps, I guess, is these combined or something like that. Maybe it's 6 and 6 right here. But the fun thing is, each of the four outputs, that is 3 amps each. So we've got 4 fuses for the 4 outputs. They're controlled by triacs. So with those, you can, of course, enable and disable, or you can PWM, you can power regulate, you can all sorts of stuff. And we got optocouplers. So this is also an added safety feature, stability feature when something goes wrong here. I don't know exactly why would you use optocouplers, because the power drive and the logic power supply will of course be the same, because one of them, we got a little local rectifier, a little PTC fuse, and a 5-volt regulator for all this little logic stuff. And then everything here is running on AC, but funny enough, they put in optocouplers for all that. And the main brain, so to speak, is an Atmel AT89C52 microcontroller. And probably for the timing settings or stuff like that, there's a little EEPROM here, a tiny little EEPROM, and a Maxim Max 813L, and a little beeper. That is the entire circuit. And the internal heatsink is not mounted to the chassis, so it can, if this one gets hot, you'll not feel it from the outside. Also, this limited cooling capability, because of the mounting here, is of course wrong when you compare to the airflow and all that. But I bet this one is not getting warm at all. A little flat cable to the front panel. And here at the front panel we see huge isolation distance, and this is classic for medical patient, anything like that, because they require a 4,000 volts isolation, and I think it's 10 minutes or something like that. Really crazy, a long time. So of course you need this really big distance. And it also says here on the transformer, this one is tested for 4,000 volts. And another fun thing, I keep finding fun things here. Look at the distance here on that circuit board. This is a lot less. And they figured out that was a problem. So they added a little plastic washer underneath the screw to add a little bit of extra millimeters. So they failed the 4,000 volts test here. And they fixed it. That is funny. They would never put in plastic washers and all this time that it takes and the risk somebody forgets this or whatever in the design if this was not super necessary to pass this test. So they need to verify this is done, and then they can sell and ship these. But I don't find anything broken or blown up or anything like that. So I think I'll just try and power it up and see what happens. I think I am ready for the first power on. I'll turn off some of the light here so we can see how much it's going to blow up. So this is I was kind of expecting, oh, it's super much flickering. So I think I changed the shutter time. But this is a little bit weird because I had the idea, okay, so now it's off. And now it's on, okay. Aha, and we got some lamps here. So warm up. Oh, that works. So this is how you turn on both of your legs. And you can what can you do? Hold this in. So that will be some. So now it's in warm up. I don't know how this. Okay, let's turn off the stop. Okay, so that works. So here's the minutes. Okay, can I program this down to 1 minute maybe? Yes, I can do that, and then start. So now it's we have a 1 minute timer. And what if I want this one over here to be on? Here you go. Is this? Look at that. Okay. 0 to 10. And then there's an end. Ende. How cool is that? So it's actually saying this in German. Yeah, of course that is cool. So we start again. Okay, so we can give it some more minutes. Okay, you can do that. And start again. I want to learn how to use the timer features here. So I think this is 0 to 10 in percent. So now it's turning on or off. This is probably a little bit annoying to watch this real bright lamp going on and off here. This is probably better, right? So, and we can turn this. So this is 10 in percent, obviously. So if I have this 1, it's going to be 1 out of 10. So it divides the time and it turns on and off like that. Of course, this is heater pads, and it takes quite a long time for this to heat up. And then it doesn't really matter. You don't need to PWM this with a high frequency. You can just do it like this. So, I mean, I can definitely use this as it is. There's just no temperature feedback or anything like that. Maybe there is a current controller. What if I disconnect this? There's no error or anything. And it's the same with the other one here. Just plug them in. And this one is also, let's turn this on and then crank it up to 10. And there you have it. So 10 is on all the time. And yeah, okay. So here is how it works. I just don't have a big understanding of that. No, this is how much time you have used it or something. Well, I don't really want to say anything more about this. It was a little bit of fun to show a little funny medical warmer project or product. So thank you very much for watching. I hope you had just a little bit of fun. See you around. Bye bye.